Okay, so in the last video we went over how to solve a redox titration. Well, now what I'm going to do is I'm going to show you guys how to solve for the empirical formula of a hydrate with a redox titration. So before, when we've done hydrate problems, basically you heat up a hydrate, it evaporates the water, and then you can look at the mass lost, and then that's going to give you the mass of water. Well, when you put a compound that's a hydrate into water, the water will break off of that compound. So right here I have hydrated ammonium iron 2 sulfate crystals. So this is what it is. It's this huge complex, and it's got so many water molecules attached to it. So remember, that's what a hydrate is. It's a crystal or an ionic compound that has water molecules surrounding it. So 8.325 grams of the salt was dissolved into 250 milliliters of acidified water, and 25 milliliters of this solution was titrated with potassium manganate with a concentration of 0.148 moles per liter. A volume of 2.25 milliliters was required. Calculate the value of X. Okay, so basically this complex was dissolved into water, 8.325 grams of it, and it was dissolved into 250 mils of acidified water, so there's acid in there to react with it. Only 25 milliliters was used, and we titrate it with potassium permanganate. So the first thing we need is the redox reaction. So on your test you will be given the reaction, and later down the line we're going to talk about more about how to predict these types of reactions. So this is our reaction right here. The permanganate is reacting with the iron in this complex right here. And one of the things that I know that permanganate, when it's put into an acid, it's an oxidizing agent, so it's going to be oxidizing something. It's going to raise the oxidation number. And if I look at this crystal, I have a transition metal in there. That's probably what's going to be reacting here. So, and we're going to go over more on how we would figure this out, but that's one way to look at it. All right, so now let's figure out our starting point. So ultimately I'm trying to figure out the number of moles of water here. So in order to do that, I need to know how many moles of salt I have versus water. So I need to know how much of the salt reacted with the permanganate. And when I look at this complex, what's going to react here is going to be the iron. So the iron is going to be the thing reacting. And since I've only got one iron in this complex, I can assume that for every 1 mole of salt that I have 1 mole of iron. So I'm going to solve for the moles of the salt here. So that's what I want. I want to get the number of moles of salt, but what's reacting in this reaction is the iron. So I'm going to be looking at it from the standpoint of the iron, but I know that if I have 1 mole of iron, I also have 1 mole of salt there. Alright, so now let's find the starting point. The starting point will be one of your reactants. Well, I'm reacting iron with permanganate. So do I have the number of moles of permanganate? What do I have? I have the molarity, and I also have the volume. So I can get the moles of permanganate. So once I have the moles of permanganate, I can figure out how many moles of iron reacted with it. And then at that point, I can figure out the moles of salt. So I'm going to go from my permanganate to iron, and then to the salt, because I know that 1 mole of iron is equal to 1 mole of salt. And then once I do that, I can figure out how many grams of water I have. So first thing, I have 2.25 milliliters. Well, anytime I'm working with molarity, I have to have it in liters, so I'm going to start off with 0.00225 liters. And I'm going to go to moles using my molarity. So moles of the permanganate on top 1 liter is equal to 0.148 moles. Now I'm going to go to moles of my iron. Well, I can use the equation for that, so I have 1 to 5, and then I'm going to go to moles of salt. So I know that for every 1 mole of salt, I have 1 mole of iron. Alright, so when I go through this and calculate that, I get 0.00165 or 665 moles of salt. Alright, so when I look back at the problem, it gives me 8.325 grams of the salt. So I need to put this in grams. So I need to know how much of this 8.325 grams actually reacted. So that'll tell me how much reacted and then how much of it was water, because water didn't really react to it. So I'm going to go to grams of the salt. And 1 mole is equal to 283.85, and that's without the water, because you don't know how much water is there. So it's 2 ammoniums and 2 sulfates and 1 iron. Alright, so now once I get that, I have 0.4726 grams of salt. But you need to be careful here, because if you read the question, it says that this was dissolved into 250 milliliters of water, but you did not use all 250. You only used 25 milliliters. So I need to figure out how much was in the original solution now. So I can't just say it's this many grams of salt. This is what reacted. I need to know of this amount right here, how much of that was the salt. So what I need to do is I need to say, okay, I actually used 25 mils of a total of 250 mils, so I used 10% of the solution. So this is only 10% of what we originally had. So 10 times that should be about 4.7 grams. That's how much of the salt would have been in the solution originally. And the way that you can do this, the easiest way to do this, is to say, okay, I know this is what reacted, and I want to know how much was originally there. You can multiply it by a fraction of how much you originally started with, so how much was in the solution, and then divide that by what you actually used. And then that's going to give you 10 anyway, so it should be 4.72 grams of salt. So 4.72 grams of salt of this substance was salt. The rest of it should be water. So to get the mass of the water, I'm going to take this and subtract my salt. And I should get 3.599 grams of water. Okay, so now this is my salt. This is my water. So now I can get the empirical formula. So remember, empirical formula, you should have the mass of each substance or the number of moles of each substance. So that's what I'm going to work on now. So I have 0.472 grams of salt, and I have 3.599 grams of water. Alright, so now next step to get empirical formula, get the number of moles. Okay, so for the number of moles of salt, I have 0.016649. And for water, I get 0.199954. Alright, so now at this point I've got moles, so now I need to divide by small. This is my smallest number, so divide both these numbers by the smallest. So this divided by this should give me 1, and this divided by this gives me about 12. So my empirical formula is I have 1 mole of salt for 12 moles of water. So that's my empirical formula.